let us look at the different types of UV radiation based on wavelength. We have short wavelength called UVC. This is 100 to 280 nanometers. It is the most damaging type of UV radiation. It is completely filtered by the atmosphere and does not reach the Earth's surface, so we are perfectly fine. The next one is the medium wavelength, which is UVB. That is 280 to 350 nanometers. It is biologically very active but cannot penetrate beyond the superficial skin layers. It is responsible for delayed tanning and burning. It enhances skin aging and promotes the development of skin cancer. Most solar UVB radiation is filtered by the atmosphere, so this is also somewhat fine. Long wavelength UVA is from 315 to 400 nanometer. This accounts approximately to 95% of the UV radiation reaching the Earth's surface. It can penetrate into deeper layers of the skin and is responsible for the immediate tanning effect. It also contributes to skin aging and wrinkling. So here is the pictorial representation of the same thing. We have the UVC radiation, which is mostly blocked in the stratosphere, so it doesn't reach even the troposphere. UVB is having the region from 280 nanometer to 320. So this can actually go up to the skin surface, but UVA is close to 400 nanometer, can actually enter up to epidermis. So these are all the three different types of UV radiation. And if you look at the ozone layer under the UV radiation, the ozone layer actually helps to prevent the UVC reaching our atmosphere. So only part of, like, even though 90% of the UVB is blocked by the ozone layer, only 5 to 10% reaches the Earth, but UVA is completely transparent to ozone layer. So every UVA reaches the Earth. So here is the pictorial representation of each type of UV radiation which is being protected by the ozone layer. So we will have some terminology called minimal erythemal dose or MED. So 1 MED has been defined as the lowest radiant exposure to UV radiation that is sufficient to produce erythema with sharp margins 24 hours after exposure. So when the term MED is used as a unit of exposure dose, we are actually representing a value for sun-sensitive individuals of 200 joules per meter square is usually chosen. A standard erythema dose has been proposed as a unit of erythemally effective UV radiation dose equivalent to 100 joules per meter square. Basically, the UV index which we generally use, like today's UV index is 10, 20, 30, 40, are calculated from 40 times the erythemally effective power of the sun in watts per meter square. So this is the unit. So based on that, we actually say what is the UV radiation on that particular day, UV index on that particular day. The term dose and the dose rate pertain to the energy and the power respectively of the striking UV radiation which is on a surface area of the irradiated object, that is unit surface area. So what is the effect of UV radiation? It is harmful to human health. The increased UVB exposure leads to higher rates of non-melanoma skin cancer and malignant melanoma. This is linked to development of even cataracts. What is the effect on plants? UVB radiation affects physiological and developmental process in plants. The direct effects can hinder plant growth, while indirect effect may alter the nutrient distribution, developing timing and secondary metabolism. There are changes which will impact the competitive balance, herbivory, plant disease and biogeochemical cycles. And what is the effect on marine systems? The phytoplankton productivity which is very foundational to aquatic food web, is negatively affected by UVB radiation. The UVB exposure reduces orientation, motility and survival rates of phytoplanktons. It damages early developmental stages of fish, shrimp, crab and amphibians, leading to decreased reproductive capacity and impaired larval development. Small increase in UVB can reduce population of small marine organisms, affecting the marine food chain. So UVB radiation is the most dangerous one for all human beings, plants and marine ecosystems. What is the effect on biogeochemical cycle? Increased UVB radiation may alter sources and sinks of greenhouse gases. They also change and contribute to biosphere-atmosphere feedbacks, impacting the atmospheric concentration of these gases. And what is the effect on materials, especially how something is exposed to UVB radiation, what will happen? Synthetic and biopolymers are adversely affected by the UVB radiation. While some material have UVB protection additives, increased UVB levels will accelerate breakdown, limiting their outdoor usability. That's the reason if you look at the tanks and other things which are made of plastic, they start degrading very quickly. That is because of the UVB radiation attacking the polymers, especially the plastics. So what are the health effects due to ozone poisoning? One is a respiratory issue, another one is a lung damage, then we also have long-term effect. The respiratory issue include irritation, that is ozone can irritate the respiratory tract leading to symptoms like coughing, throat irritation and shortness breath. It also aggravates asthma. It decreases the lung function and also increases inflammation. The chronic respiratory disease and impact on heart health are the long-term effects of ozone poisoning. What is the impact on the Arctic region? The impact on melting ice, we can see the reduction in snow and sea ice reflectivity predicted to decrease above surface ultraviolet index of up to 10% in the Arctic region. This leads to increased UV penetration, that is increasingly ice-free Arctic Ocean will lead to greater UV radiation penetrating the water column, which will affect basically the phytoplankton which are living in that ocean. The land surfaces previously covered by snow will also experience higher UV exposure. With respect to aerosol concentration change, the concentration decreases in the aerosol over northern hemisphere urban areas, which is projected to be increased by around 5 to 10% because of this UV radiation.